Alright, today what we are going to be working on is graphing polynomial functions. There's a lot of little pieces to graphing, and so I'm going to point out some things that I want you to get down. Make sure you get them down, and there are several different topics to discuss, so let me jump right into it. Again, we're graphing polynomial functions. What we have here first is common polynomial functions. Alright? And I say function, almost you can be used as an equation a lot of times. So anyway, constant. Whenever you see this right here, any of those, f of x is not f times x. That's like saying y. So this is like y equals 14, y equals mx plus b, which is linear line, quadratic, which is what we talked about earlier. That's the U-shaped parabolas, and cubic, the highest exponent. Remember, the degree is the biggest exponent, and so these should match. Notice here. These are the common polynomial functions. We should know what a line looks like in general, and what a quadratic equation looks like in general, and what a cubic equation looks like in general. Alright? And so that's the first thing we're going to talk about. Alright, this first section is going to go pretty quick. I want to talk about parent graph transformations. And what you have here is my little ugly sketches of what I call parent graphs, meaning these are the beginnings. And every graph follows one of these. This is y equals x, where your y-intercept is 0 and your slope is 1. You can transform this, meaning you can move this line up 1 like that, or over 2 like that, and you can move them by what's called transformations. Alright? Now, it's basically like this. If you want to move a graph to the left or to the right, you have to put your variable in parentheses and add or subtract, which is strange. If you want to move to the right, you would think you would do plus, but to the right is minus a number. And if you want to move to the left, is x plus a number. So, an example, well, we'll talk about that here in a second. But you can actually move this up and down and left and right by keeping this in mind. Same thing over here. Y equals x minus 2 squared. What that does is take the vertex right here and moves it to the right 2. And so now this parabola is shifted over. Now, if I said y equals x squared plus 2, when you do adding or subtracting, that's going to move your parent graph up or down. Up if the number is positive that you add or subtract, or that you're adding a number, and down if you are subtracting or the number is negative. So if a number is outside parentheses, this is what you need to know. The short thing is this. Whenever you have a number added or subtracted to the outside of your parentheses, it moves your parent graph up or down. Up if the number is positive, down if the number is negative. So if I had an equation y equals x squared minus 4, that would take this right here and move it 1, 2, 3, 4 down, and so it would look like this. So how do you move it, left or right? Well, it has to be inside parentheses, and it's opposite of the direction you would expect. Up and down goes in the direction of the number, which makes sense. Going up is positive, going down is negative. So if I say plus a number, you would think you would go up. If I say minus a number, you would go down. That makes sense. However, when it's inside parentheses, it goes opposite in the left and the right direction. So just keep that in mind. It shifts the left and the right inside parentheses in the opposite direction. This is a cubic graph right here. Same apply there. And this is a fourth degree polynomial. Now, this is just a general one. This is not exactly this equation here. And so we need to actually talk about this. So the first part of the notes is very simply talking about how to transform or move a graph to the left or to the right. Inside parentheses, it's going to move left or to the right horizontally. Outside parentheses, a number is going to make it go up and down. Both of those are instances of addition and subtraction. It's not multiplication that I'm talking about there. Now that last one I had was a 4th degree polynomial, and I want to talk about that real quick. We're going to go into talking about how to graph those, and we're going to use graphing calculators. I'm going to just be honest with you, it's just easy to use graphing calculators. We should be able to use those effectively. But you should be able to look at an equation, and so you need to make sure you get this down, all this here, and know how it ends. I can tell by the degree and the leading coefficient what this kind of overall graph should look like. So these two is the degree is odd. Notice if the degree is odd, how the graph looks. And if the degree is odd, how the graph looks. What does this mean? Notice this stuff all right here. What that means is, as this is going to positive infinity, as this side is going to negative infinity for the x-axis. Going to negative infinity over here, going to positive infinity. That's what all this little stuff is talking about. So if your leading coefficient is positive, it's going to be positive going to the right. It's going to be going up to the right and down to the left. Now, if it's negative, that's going to be flipped. If your leading coefficient is negative, it's going to be going up to the left and down to the right. It can do a whole bunch of funky little stuff in between, but we know the end behavior looks like that, how it ends. Understand we're talking about the end behavior, not the whole graph, just what it looks like at the end. All right? Now, if the degree is even, if the leading coefficient is positive, it's going to be both of them going to go in the same direction up. If the degree is even and the leading coefficient is negative, both going to be going in the same direction down. So what's a difference here? If you have an odd degree, they're going to be going, the ends are going to be going from left and to right are going to be going in different directions, meaning positive infinity and negative infinity are going to be going in different directions. How do you tell? If your leading coefficient is positive, it's going up on the positive infinity and going down negative infinity. If the leading coefficient is negative, it's going up in the negative infinity side and down on the positive infinity side, like going to the right, down, going to the left, up. However you need to remember that. Now, if your degree is even, then I can look at this and say, okay, if my leading coefficient is positive, they both go up in the same direction. And if the leading coefficient is negative, they both go down in the same direction. So even degree polynomials end in the same direction, both up and both down. Think about parabolas. They both end pointing up or pointing down. Any 2, 4, 6, 8 degree polynomial, then they're always going to end in the same place, pointing up or pointing down. How do you know the difference? Well, you got to look at the leading coefficient. Is it positive or is it negative? That's really self-explanatory. Alright, next thing I want to talk about is how to evaluate a polynomial. Sometimes we're going to want to make a chart, a little X and Y chart, and we want to figure out what are the points so that we can figure out what the graph looks like. Because remember, whenever you have to graph, you can always make a chart. Independent and dependent variable, meaning X can be whatever you want to. We substitute X into the equation and figure out what Y is. And so I'm going to show you two different ways to evaluate a polynomial. The first way is to take the variable or the value that they give you and substitute it in for X everywhere that there's an X. Alright? Alright, so what I did is went ahead and simplified this for you, and f of 3, I made a mistake there, should equal 23. Whenever you substitute 3 in for X, you should get 23. And so if I slid over here, my table would look like this: 3, then 23. Now, that's called direct substitution, where you directly take the value that they give you and substitute it in the polynomial for X. And that's what I did here. That's what this is. That's an ugly looking 3, but that's a 3. And when you simplify, you should get 23. Now, that's called direct substitution. You can also do synthetic division and do the same thing, except for this last column not being your remainder, but it should give you 23. If you do synthetic division, the last number that you get should be what you would get if you substitute. So this is another way of figuring out what your value will be. So I took the 3 and I put it in the little window there. Notice I didn't change the sign. I just took the 3 as it looked. Why? Because it's saying x equals 3. It's not x minus 3 or x plus 3. So it's telling me what x is. So I put it there, and I put the coefficients all. Notice I put a 0 in because there is no x squared. And so now let's see if I get 23. Bring your 2 down. 2 times 3 is 6. Negative 5 and 6 make a 1. And that's a 3. That's 3. That's 9. And what is that? 5. 5 and 3 is 15. 8 and 5 makes Michael Jordan. Haha, 23. So what am I trying to tell you? A way to evaluate a polynomial, 2 ways actually. One is direct substitution, something that we should know how to do. The other is actually using synthetic division. And you can do synthetic division and get the same value as if you would have took this number and substituted it in for x. Alright, one of the next aspects, or the last aspects I want to talk about for graphing, before I actually just show you how to graph on a graphing calculator. Remember, everything I'm doing is little pieces to help us understand how to graph. So whenever we do it in class, you'll know that you've talked about each one of these pieces. You'll see the phrase local maximum or relative maximum or minimum. Look at this graph right here. They're not really the actual maximum point or the minimum point, meaning the highest most point or the lowest most point. It's just locally in that area or relative to the space around it, that's the highest point and the lowest point. Sometimes they're called turning points, all right? And simply put, they'll ask you for the local minimum. What they're asking for is the y coordinate, okay, or the y coordinate of that point. And so we could actually figure that out if we knew the x value. And so, listen, it says, this right here is an important thing to know. Whatever the degree is, take 1 from it, and you have at most that many turning points. So if I got a cubic equation, I got at least 2, because I subtract 1 from it, turning points. That's a cubic, by the way. If a polynomial function has however many real zeros, then you subtract that 1. So these are just concepts telling you I know how many turning points I have without doing any graphing. And the turning points are actually called maximum and minimum. So what's the difference? The maximum would be the high point. The minimum would be the low point. The maximum is not always going to be on the left-hand side of the y-axis, and the maximum on the minimum on the right. It's just wherever they choose to be, you will have maximums and minimums. All right? So get that down. All right, let's look at number 22. We should be able to tell what this graph kind of looks like. All right? It's a cubic, or it's an odd power function, odd degree, and the first coefficient is positive. Okay, so it's an odd degree and the leading coefficient is positive. All right, what did the note say about that? Odd degree, leading coefficient positive. It should look like this: go down on the left hand side and go up positive infinity, negative infinity is what I really should be saying. So what did I do? I went ahead and graphed this in what we're going to be using later, graphing calculators. And look how it looks. It's going down from left to right. Now, you don't see the whole picture. And it's not like 3D and 4G ultimate pixels and all that kind of stuff. It's very basic. But notice, it's going up, it's going down, it's going up. And as you go to positive infinity, it's going up. It's acting right. Now, notice how many times it crosses the x-axis. 1, 2, 3. Those are your solutions, or your x-intercepts, or your zeros. When you find zeros, that's where they cross the axis. And there's this thing called the fundamental theorem of algebra that says if your exponent is 3, that's how many times at most you should cross the x-axis. And so that's what happened here. How did I input this? This button right here says y equals, and I put that equation in. Then I hit this button over here, graph, and it gave me that. Since I've been gone a lot, this is how we're going to actually do our graphing. We're just going to use the graphing calculator, but we need to be able to tell basic information like how it goes up, the minimum here, the relative minimum, the zeros here. We need to be able to read those things, the end behavior of a graph. We need to be able to check those things out, and all those things were covered in the notes today. I know that's a lot, and we'll talk more about it in class. Peace.